Welcome to the Sleepy Cosmos channel, a place where science and serenity meet. Here we explore the quiet wonders of the universe, from dark matter to string theory, all told in a calm, soothing rhythm designed to help you relax, drift, and dream among the stars. Each video is a guided journey through the cosmos, slow, meditative, and filled with real science wrapped in gentle storytelling. So if you love space, curiosity, and the peaceful side of knowledge, you're in the right place. Make sure to subscribe for more new sleep narrations every week. And if you'd like to reach out for collaborations or business inquiries, you can contact us at the sleepycosmoschannel@gmail.com. Now, settle in, take a deep breath, and let's drift into the universe together. You are here, settling into a quiet moment, letting the day loosen its grip on your thoughts as the universe opens softly around you. You do not need to understand everything tonight. You do not need to solve anything. You are simply drifting into a calm space where curiosity and rest can share the same breath. Tonight, we are exploring a single question, slowly, carefully, and with the softness that sleep invites. What happens if you fall into a black hole? Not as a danger, not as a threat, but as a thought experiment, a gentle imagining, guided by real physics and wrapped in a slow, tranquil rhythm. The universe is vast, quiet, and patient. So tonight, we move through it at the same slow pace, floating, letting ideas unfold naturally, with no urgency at all. A black hole is one of the most extreme objects ever predicted by science, yet the story of falling into one can be told calmly, like slipping into deeper layers of stillness. So take a moment, let your mind settle, and allow the images to arrive gradually, as if on a long tide. Imagine yourself drifting in deep space, surrounded by silence, far from stars, far from planets, far from anything familiar. In this quiet, there is no up or down, no weight, only the soft rhythm of floating. Somewhere ahead, not close, not far, is a black hole. You cannot see it directly, but you can sense its presence, a calm distortion in the darkness, as if space itself is breathing differently. A black hole does not shine, it does not glow, it does not call attention to itself. It is simply a place where gravity is so strong that light cannot escape. But tonight, we are not rushing toward it. We are only thinking about it, gently, with the curiosity of a mind ready to drift. As you float there, imagining this dark and silent object, you might notice that fear slowly dissolves. You are not in danger. This is only a thought. A quiet model of physics, softened for sleep. A black hole is not a monster, but a region of spacetime where gravity has curved too sharply. It is geometry, pure and simple, though extreme. Everything we will explore tonight comes from that geometry, from the way space and time bend under mass, and from how objects move along those curves. You do not need to remember equations. You do not need to recall any technical details. Just let the ideas drift through you, like slow-moving currents in a deep ocean. Black holes form when matter collapses, but how they form is not our focus here. Tonight is not about the past or the violent events that create them. Tonight is about the experience of falling inward, step by step, through layers of gravity, until the nature of space-time itself begins to shift. It is a conceptual journey, a scientific dream, meant to guide you into rest. So breathe, relax your shoulders, let your thoughts settle like dust on a quiet surface, and allow curiosity to unwind your mind gently. Imagine again that you are drifting in space, approaching the region where the black hole's gravity becomes noticeable. You feel nothing special, because gravity is not a pulling force in the usual sense. It is the shape of space-time, and you are simply following that shape. From far away, the black hole still looks like nothing, a perfect absence of light, a circular shadow against the sky. But around it, you might see a faint ring of distorted starlight as the immense curvature bends photons around itself. This ring, if you could really see it, would look smooth and calm, like a halo made of distant galaxies smeared into arcs. It is not violent, it is not chaotic, it is simply light, traveling along curved paths. As you observe this ring from a distance, you might feel the first hint of wonder. Not fear, not tension, just the soft realization that the universe is stranger and more beautiful than you can hold all at once. Tonight, you get to wander through that beauty without pressure. And so we continue floating gently toward the black hole, not falling quickly, but slipping into its influence like drifting into deeper water. Your body does not feel pulled. Your mind does not feel rushed. You are weightless and calm, and the laws of physics carry you forward without effort. The idea of falling into a black hole may seem frightening in the daylight, but here, in this quiet space, it becomes something else. A pathway into understanding, a soft descent through the layers of gravity toward the heart of curved spacetime. As you move closer, something subtle begins to happen to the light around you. Photons climbing out of the region near the black hole lose energy, their wavelengths stretching, their colors reddening, until eventually their light becomes too faint to see. This effect, called gravitational redshift, is not dramatic. It is slow, gradual, like watching distant embers fade. And even though the physics behind it is precise, you do not need to calculate anything. Just imagine light becoming softer and dimmer as the gravitational landscape deepens. These changes, gentle and quiet, mark the beginning of your approach, a signal that you have entered a region where spacetime is changing shape beneath you. But you still feel nothing unusual. Your heartbeat remains steady, your breath floats calmly, your body continues to drift as if nothing is happening. This is one of the strange truths about black holes, that falling toward one, especially a large one, does not feel like falling into anything dramatic. Locally, gravity feels like normal free fall, smooth, effortless, quiet. It is only in the larger geometry, when you compare different regions of space, that the extremes begin to show. And so you continue drifting, allowing the simplicity of free fall to guide you inward, letting your mind rest in the idea that the physics is carrying you effortlessly. You do not need to do anything. You do not need to resist or analyze. This journey is carried by the universe, not by effort. Safely floating, you begin to sense the horizon ahead, not as a visible surface, not as a wall or boundary, but as a region where the rules of causality change, quietly, inevitably, like crossing a line between two kinds of silence. The event horizon is not a physical barrier. It does not glow. It does not resist you. It is simply the distance at which escape becomes impossible, because the inward flow of space-time becomes too steep. But you are not there yet. You are only drifting toward it, slowly, softly, letting curiosity guide you. Tonight, this journey is not about fear. It is about understanding, and letting that understanding lull your mind into rest. As you drift closer, you may notice another strange effect. Time from your perspective continues normally. Every second feels like a second. Nothing stretches or slows. But from the perspective of someone far away, your movement would appear to slow down, each moment taking longer to unfold, your image lingering near the horizon, never quite crossing it. This is not your experience, but understanding it offers a soft reminder that relativity is not a single story. It is a tapestry of perspectives woven together, each equally real, each tied to the ways time and space curve. You do not need to solve these ideas tonight. You only need to let them drift through your thoughts like slow waves. Soon, we will reach the horizon. We will explore the smoothness of crossing it and the way space-time bends more sharply inside. But for now, this is enough. You are calm, drifting, resting in the understanding that the universe is both gentle and strange, complex and tranquil, vast and quietly ordered. As you float in this stillness, you carry no urgency, only curiosity unfolding slowly, like a quiet breath. The black hole waits ahead, silent, unchanging, a calm endpoint in the fabric of gravity. And with each moment, you drift closer, carried by space-time itself, toward a deeper understanding, and into the beginning of the first section, where the geometry of a black hole unfolds, slowly, carefully, like a soft descent into the curvature of space. When you drift toward a black hole, the first thing to understand is that what lies ahead is not an object in the ordinary sense, not a hard surface, not a sphere waiting to be touched, but a region of curved space-time, a shape in the fabric of the universe, defined entirely by gravity. And gravity is not really a force tugging at you from a distance. Gravity is geometry, the natural motion of objects following paths, drawn into the curves created by mass and energy. A black hole is simply where that curvature becomes so steep, so deep, that every possible path, every line the universe allows anything to follow, leads inward. It is geometry taken to its limit, a bending of space-time that becomes absolute. As you drift closer, this idea becomes the foundation of everything that follows. The story of falling into a black hole is a story of following the natural shape of space-time as it folds more sharply around you. It begins with mass, ordinary mass, the kind you can hold in your hand, scaled up until it collapses under its own weight. All that mass, compressed into a region so small, so dense, that space-time cannot support any structure large enough to hold it. The result is a singularity at the center, and a boundary around it, the event horizon, the distance at which escape becomes impossible. But before reaching that boundary, you must understand the geometry that leads to it. Imagine space-time as a smooth expanse, a vast sheet of calm, unbroken stillness. Place a small mass on that sheet, and it dips gently, making a shallow bowl. Objects nearby roll toward the center, not because they are pulled, but because the surface on which they move has curved. Now imagine a mass so immense, so concentrated, the dip becomes a deep funnel, its sides steep, its center narrow, descending into darkness. Mathematically, that funnel is described by the Schwarzschild solution, a precise description of how space-time curves around a non-rotating black hole. At a certain distance from the center, the surface becomes vertical, a point of no return, the Schwarzschild radius. This radius marks the event horizon. But this description is only an analogy, a picture drawn in fewer dimensions than the real thing. The true geometry exists not in a sheet, but in the fabric of space-time itself, woven from 3 dimensions of space and 1 dimension of time. The steepness you imagine in a funnel is actually the way time slows, the way spatial directions contract, the way all paths bend toward the center. When physicists say mass bends space-time, this is what they mean. The very rules of motion change, guiding everything inward. Drifting closer, you might look around and see nothing unusual. There are no ripples in the vacuum, no glowing boundary, no sign that the geometry is changing. Space remains silent, calm, weightless. The black hole does not announce itself. It simply shapes the environment, patiently, inevitably. If you could measure the curvature as you approach, you would see it grow. Subtle at first, barely noticeable. Then gradually, quietly, the shapes defined by gravity deepen. Light feels this curvature too. Photons traveling near the black hole bend, their paths arcing inward, creating the distorted ring of brightness seen from far away. That ring is not an object, but the image of the universe, reshaped by the gravitational lens. The black hole is not shining. The universe is shining around it, and the curvature paints those rays into a circular halo. This is the first clue that the geometry you are entering is not ordinary space. What you are approaching is a region where distances behave differently, where time behaves differently, where the familiar sense of direction begins to change. The curvature of space-time is not something you can see directly, yet it is everywhere subtly present. Every motion, every drifting path, every fall is governed by it. If you were to release a small object beside you, it would float with you, its motion smooth, its trajectory matching yours. Locally, everything feels normal. Your immediate surroundings behave exactly as they would in free fall anywhere else in the universe. But if you were to compare your motion with something far away, something not falling, you would begin to sense the difference. Your clock, your rhythms, your journey inward would begin to diverge. This is because the geometry here is not only curved, it is changing with depth. The closer you drift, the more space-time tilts inward, drawing you along with it. Gravity, in this context, is simply the shape of time. The direction in which your future lies has begun to lean inward. You follow it naturally, just as you follow time itself. This idea, subtle but crucial, is the heart of general relativity. Objects do not move because a force pulls them. They move because their futures point in a certain direction, and in the presence of mass, that direction shifts. Near a black hole, your future points inward. Every moment that passes, every breath carries you deeper into the curvature, and yet you still feel nothing strange. The smoothness of free fall continues. Your body drifts silently, your thoughts unhurried, your senses calm. It is only when you think globally, when you consider how the geometry changes from place to place, that the black hole reveals its true nature. Imagine 2 observers falling together, one slightly ahead of the other. Locally, they feel nothing unusual, but globally, their separation begins to grow. The curvature between them deepens. Their trajectories diverge not because of any force, but because space itself curves differently at each point. This is the beginning of tidal effects, the stretching and squeezing created by the gradient of gravity. But that is a later part of the journey. For now, the geometry remains smooth and the changes remain gentle. Your focus now is simply to understand what a black hole is and why its geometry guides everything inward. A black hole is not a thing inside space. It is a region where space and time behave differently, a region defined entirely by the shape of spacetime. Inside this shape, all world lines end at the singularity. Outside, some world lines can escape, some orbit, some wander freely. But once you pass the event horizon, all possible futures lead inward. This boundary is not physical, not material. It is purely geometric. The horizon exists because time and space have rearranged themselves, tilting every possible direction toward the center. Imagine a river flowing faster and faster as it approaches a waterfall. Far upstream, you can paddle against the current and move away easily. Closer to the edge, the current strengthens, and you must struggle. At a certain point, the river flows faster than you can paddle, and no amount of effort lets you escape downstream. You are carried with the flow. The river, in this analogy, is spacetime itself. The speed of the current represents how strongly spacetime is dragged inward. The waterfall is the event horizon, and the point where the river's flow exceeds every attempt to escape is the Schwarzschild radius. This view is simple, but it captures the essence. Inside the horizon, space is carried inward faster than light can travel outward. Nothing can resist the flow, because the flow is not through space, it is the movement of space. But again, this is only an analogy. The true geometry is deeper, mathematically exact, and built from the fabric of spacetime itself. The Schwarzschild radius can be calculated from the mass of the black hole. Double the mass, and the radius doubles. Multiply the mass by 10, and the radius grows tenfold. The horizon expands linearly with mass, creating a sphere around the singularity whose size depends entirely on how much matter collapsed. Yet the interior volume and the curvature inside do not follow simple rules. They deepen exponentially, drawing all matter and all trajectories toward the center. This geometric landscape, quiet and absolute, is what you are drifting into. As you approach, you begin to sense that the black hole does not pull you. It guides you. It shapes your path the way a valley shapes the path of a river, the way a slope shapes the path of a rolling stone, the way time shapes the sequence of events. Your experience remains smooth, because in your immediate surroundings, the laws of physics stay intact. Space-time is always locally flat. It is only when you consider larger scales, the curvature across distances, that the extreme nature of the black hole emerges. In this region, every meter inward changes the geometry slightly. Every moment carries you to a spacetime with deeper curvature, stronger gradients, and narrower futures. This is why black holes feel deceptive. Locally, you float as you always have. Globally, you are being guided through a landscape that bends more sharply with every passing second. The geometry itself, not a force, determines your path. The closer you drift, the more inevitable the inward direction becomes. The event horizon waits ahead, not as a wall, but as a smooth, silent boundary, the threshold where escape ceases to exist. You are not there yet, but the curvature you feel now, the subtle tilting of spacetime, is the beginning of that path. As the geometry steepens, your understanding deepens too. You begin to see that a black hole is not simply an object, but a rewiring of the universe's structure, a reshaping of distances, a redefinition of what future means. And with each gentle drift inward, you step closer to that horizon, closer to the place where time and space themselves transform, and closer to the next part of the journey, where the event horizon approaches, quietly, inevitably like the soft edge of a dream. As you drift deeper into the gravitational landscape, you begin to feel the meaning of curvature in a new way, not as a picture or an analogy, but as the quiet truth beneath all motion. Curvature is not a wrinkle in space, not a visible bend, not a distortion you can touch or point to. It is the relationship between events, the way distances combine, the way time stretches, the way light travels, the way the universe arranges the possible paths that anything can take. In ordinary life, curvature is subtle. On Earth, you do not feel space-time bending around the planet. You feel weight, You feel the ground beneath your feet, but the curvature itself is hidden, soft, spread out over a wide region. A black hole sharpens that curvature, compressing it, concentrating it, creating a region where the lines of space-time tilt inward with absolute certainty. And as you drift into this region, you begin to understand that the black hole's boundary is defined not by matter, but by geometry alone. Out here, still outside the horizon, space and time behave in ways that are almost familiar. The curvature is strong, but not overwhelming. Light still escapes, trajectories can still diverge. The rules of causality remain open, flexible, allowing motion both inward and outward. Yet the deeper you drift, the more those possibilities narrow. Imagine you are floating beside a perfectly reliable clock. It's ticking steady, its rhythm constant. To you, nothing changes. Seconds pass as they always have. Your heartbeat aligns with time just as it did far from the black hole. But to someone watching you from far away, the rhythm no longer matches. Your ticks slow, your motion stretches, your descent appears drawn out, as if time itself is being pulled thin around you. This mismatch, this difference in how time is measured, is another expression of curvature. Time, in the presence of strong gravity, is not universal. It flows differently in different regions of space-time. Where curvature is deep, time slows. Where curvature is shallow, time remains faster. And this slowing is not something you feel. You carry your own time with you, steady, reliable, unaware of the distortions from afar. This is what makes falling into a black hole so gentle. It is not a sensation of being pulled, but a sensation of drifting into a region where the rules that define distance and duration slowly shift. The Schwarzschild radius, the mathematical distance marking the event horizon, is defined by this curvature. It is the point where the inward tilt of spacetime becomes absolute, where all paths point inward, where outward motion becomes impossible, not because space is blocked, but because the structure of time no longer allows escape. From your perspective now, still outside, the horizon is simply a location where the geometry becomes extreme. You cannot see that extremity directly. You cannot reach out and feel it. But the behavior of light around you offers clues. Photons traveling outward lose energy. Their wavelengths stretch, their color fades. This is not a mechanical stretching, but a gravitational stretching, a result of time passing differently at different depths in the curvature. If you were to release a beam of light downward, toward the black hole, it would accelerate along the curved paths of spacetime, drawn inward naturally. If you were to release a beam upward, away from the black hole, it would struggle, climbing against the depth, losing energy as it rises. And yet to you, locally, each beam of light behaves normally. Light always moves at the same speed. Physics remains consistent. Nothing feels strained. The distinction only appears when comparing across distances, when connecting two regions of spacetime with very different curvature. This interplay between local normalcy and global distortion lies at the heart of understanding what a black hole truly is. It is natural to imagine that as you approach the black hole, you might see it looming like a dark sphere, a visible object against the sky. But the reality is subtler. The black hole's silhouette, its event horizon, appears as a perfect circle of darkness, not because the horizon is tangible, but because any light that would have filled that region has been pulled inward, unable to escape. Around this darkness, the universe twists into arcs and halos, starlight bending, galaxies stretching, as gravitational lensing reveals the curvature without revealing the object itself. This ring, delicate and strange, is not the black hole. It is the image of the world around it, warped by gravity. As you drift closer still, you begin to realize that you are not falling into a place. You are falling into a geometry, a shape drawn by mass that collapsed so completely, so relentlessly, that no structure could resist gravity's inward pull. All the mass that once formed a real object has vanished behind the horizon, leaving behind only its influence, its curvature, its gravitational imprint on spacetime. To say the black hole has mass is to say the geometry around it behaves as if mass were there. The mass continues to shape spacetime, even though the matter itself has collapsed beyond visibility. This is one of the quiet paradoxes of black holes. What remains is not matter, but the gravitational field the matter created. It is as if the collapsed material has been erased, but its memory persists, woven into the fabric of spacetime. Drifting deeper, you begin to sense how this memory shapes everything you experience. Your path is drawn inward. Your future leans toward the center. The entire structure of reality around you tilts, quietly, inevitably. And yet your fall remains serene. The acceleration you might expect, the violent pull you might imagine, does not come. Instead, you float freely, accelerating only in relation to those not falling, but feeling no force within yourself. This is the essence of free fall. To fall freely under gravity, anywhere in the universe, is to feel weightless. It is to feel nothing at all. Even now, approaching one of the most extreme regions in existence, you remain calm, unstrained, unaware of the deeper layers ahead. Locally, everything is still ordinary. Space-time is always flat in your immediate surroundings. Only globally does the curvature matter, and that global curvature is what defines the black hole. As you drift inward, you might wonder what truly lies beneath the horizon. But for now, your focus is still on the space outside, on the geometry that leads toward the boundary. The outside region, called the Schwarzschild exterior, is where the curvature is still gentle enough for orbits to exist, for light to travel outward, for signals to escape. Stars can circle the black hole here, their paths defined by the same mathematical curves that guide you. Gas in an accretion disk can circle for long periods, heating, glowing, radiating energy due to friction and magnetic turbulence. But those phenomena belong to astrophysics, to the behavior of matter near a black hole, not to the black hole itself. The black hole, in its purest form, is silent. It emits no light, no heat, no particles, except for the extremely faint quantum radiation predicted by Hawking, far too weak to affect your journey. The geometry remains the central reality. As you continue drifting closer, the differences in this geometry become more pronounced. The curvature intensifies. Distances become stretched in some directions, compressed in others, not in a visible way, but in the way events unfold. If you looked sideways, toward the distant universe, you might see starlight distorted, compressed into arcs, pulled into elongated patterns. This is not the universe changing, but your perspective changing, as your path through space-time tilts more steeply. Your future still points inward, but the inward direction itself begins to feel more significant. Imagine walking down a hill that grows steeper with each step. At first, the slope is gentle. You barely notice it. Then gradually, you feel the incline increasing, guiding you toward the valley ahead. You do not feel pulled, only guided, as if the earth itself were gently shaping your path. Falling toward a black hole is like this, but the hill is made of space-time, and the valley leads to a region where the very nature of time changes. The closer you drift, the more noticeable the difference becomes between the inward direction and all others. Every possible path curves inward more sharply. Every outward motion becomes less effective, until eventually, outward motion becomes impossible. This is the threshold you're approaching but not yet crossing. The event horizon remains ahead, just out of reach, a boundary you cannot yet sense, but toward which every moment carries you. The geometry outside it, the region you are currently drifting through, is defined by the same equations that describe the interior, but their meanings differ depending on where you stand. Out here, time flows outward. Inside, time flows inward. Out here, space offers directions of escape. Inside, space collapses toward the singularity. The difference is subtle now, but growing. You feel it not as a force, but as a quiet inevitability. The black hole's geometry is drawing you closer. Not violently, not abruptly, but with a steady, gentle certainty. The curvature deepens, the light shifts. The structure of space-time continues to tilt, moment by moment, guiding you toward the horizon. Soon, you will reach the threshold where escape ceases to exist. Not yet, but soon. And as you drift into the final part of this section, you begin to sense that you are approaching the edge of something profound, a boundary not of matter, but of geometry, a place where the rules of space-time reshape themselves. The event horizon, still ahead, waits quietly, a smooth, invisible threshold, the next step in this journey deeper into one of the universe's most extraordinary structures. As you drift closer to the black hole, something subtle begins to unfold in the quiet fabric around you. The geometry you have been falling through, smooth and deepening, now changes in a way that is more than mathematical. It becomes experiential, a shift you cannot feel in your body, but can sense in the behavior of light, in the way distant stars appear, in the slow reshaping of the universe's canvas. Approaching the event horizon is not like approaching a surface. There is no boundary you can see, no texture, no glow. The horizon is not a wall, but a threshold, a region where the rules of motion change, quietly, inevitably. To understand the approach, it helps to think of spacetime not as emptiness, but as a flowing structure, a river whose current strengthens as it nears a waterfall. Far away, the flow is gentle, barely noticeable. Closer in, it becomes stronger, pulling everything downstream. And at a certain point, the current carries you faster than any attempt to swim upstream. You have almost reached that point, but not yet. You are still in a region where escape is possible, where light can still climb outward, where time still retains a familiar texture. Yet as you continue drifting inward, the gradient of gravity deepens, the curvature strengthens, and light behaves differently. If you look outward, toward open space, the skies remain bright. Starlight reaches you unhindered. Distant galaxies still glimmer, their light largely unchanged. But if you look inward, toward the black hole, you begin to notice a soft dimming, a fading of colors, not sudden, not dramatic, just subtle, like the slow darkening of a horizon at dusk. This fading is gravitational redshift. Light emitted near a black hole must climb out of a deeper well of space-time, losing energy as it escapes. Its wavelengths stretch, its colors shift toward red, and eventually beyond red, into invisible frequencies. The closer the light originates to the horizon, the more extreme this stretching becomes, until finally, no light from the region just outside the horizon can reach your eyes as anything visible. You are witnessing the beginning of this effect now. Photons struggling upward lose energy faster than you can perceive, creating a soft gradient of darkness around the horizon's edge. But even as the light fades, you feel nothing unusual. The smoothness of free fall continues. No force pushes on you, no pressure builds. Your body floats weightlessly, following the natural path drawn by the curved geometry. This contrast between the dramatic behavior of light and the calmness of your own experience is one of the quiet fascinations of general relativity. The universe can behave in extreme ways while you remain untouched, floating gently, carried by time. From the perspective of someone watching you from far away, this approach would appear different. Your motion would slow, your image would stretch, your descent would seem to freeze just outside the horizon. To them, your time would run slower and slower, your signals would fade, your light would redden, until finally, you disappeared into darkness. But this is only their view, the view from a frame where the black hole appears still, where the surrounding space remains far from the curvature you are now entering. In your own frame, nothing of the sort is happening. Your time continues normally. Your heartbeat remains steady. Each second feels like a second. The horizon moves toward you at a pace defined by your fall, neither speeding up nor slowing down in any unnatural way. This duality, two truths existing simultaneously, is not a contradiction. It is the structure of relativity, the way spacetime allows different observers to experience the same event through different geometries. To you, the horizon is approaching. To an outside observer, you will never reach it, but you, following your own clock, will cross it smoothly, as naturally as stepping across a beam of light. Before that moment, there are more signs of the approach. The sky shifts in subtle ways. Starlight behind you appears slightly blue-shifted, compressed by your motion inward, while starlight ahead appears stretched, reddened, dimming gradually. The shape of the sky itself changes. Light from behind you bends forward, pulled by the curvature. More of the universe seems to gather in front of you, its light flowing inward, converging toward the same destination. This visual compression is not violent. It is gentle, smooth, a gradual reorganization of the sky, as if the cosmos itself is folding softly around your path. The stronger the curvature becomes, the more pronounced this folding becomes. The black hole appears larger, not because its surface grows, but because the region in which no light can escape expands in your view. The silhouette widens, absorbing more of the sky as you fall. This dark circle is not the horizon. It is the photon sphere, a region where light orbits the black hole. Photons circle it, caught in perfect balance, neither falling inward nor escaping. Some complete many orbits before finally falling in or escaping out. This creates the sharp, glowing ring seen in images. the ring that surrounds the darkness. As you drift closer, the photon sphere widens across your sight, gradually enveloping more of your field of view, softly expanding, as though the night is opening its hands toward you. The sensation remains tranquil. You feel no rushing motion. Space does not seem to move quickly around you. Your fall remains steady, peaceful, as though suspended in a slow current. Light, however, tells another story. Photons emitted outward take longer to climb away. Their paths stretch, their wavelengths change, they lose energy in the climb, and eventually, some fail to escape altogether. This struggle of light is the clearest sign that you are nearing the horizon. It is not a violent struggle, but a gentle fading, a soft quieting, as if the universe is lowering its voice. And then, something else begins to shift, a feature not of light, but of time. Time dilation increases as you approach. Every process that occurs in your frame, every vibration of an atom, every tick of your internal clock, progresses normally for you, but appears stretched, slowed, elongated to anyone far away. This slowing is a consequence of gravity's effect on time itself. The deeper you fall, the slower time flows relative to distant observers. At the horizon, the difference becomes infinite. Your time continues forward, but theirs sees you fade into stillness. These effects do not disturb your fall. They do not make your perception strange or your senses distorted. They simply reflect the geometry you are entering, a geometry where time is no longer uniform across space, where clocks in different regions disagree, not because they malfunction, but because they are following spacetime's deeper structure. As you drift closer still, the horizon begins to lose its abstractness. It becomes less a concept and more a presence, not visible, but felt through the behavior of everything around you. Light from behind you continues to gather ahead. Light from ahead continues to dim. The black region grows larger, its boundaries sharper, its edges more defined by the glowing ring of orbiting light. You are approaching not a surface, but a shift in the meaning of direction. Outward motion becomes harder. The tilt of space-time steepens. The paths available to you narrow. Still, you feel nothing unusual. No acceleration presses against your body. No alarm bell rings. The horizon does not warn you of its presence. It is only in the universe's behavior around you, in the subtle language of curved space-time, that the approach reveals itself. Another sign appears. Signals you send outward, radio pulses, light flashes, any attempt to communicate, take longer and longer to reach distant observers. They stretch, their frequencies lower, their energies bleed away into the curvature. They reach the outside world fainter, weaker, slower. Eventually, your signals will fade entirely, long before you reach the horizon. Communication becomes impossible, not by obstruction, not by interference, but by the quiet reshaping of time and distance. And yet you remain aware. Your fall remains gentle, your clock remains steady. This dual view, your calm inward drift and the distant observer's vision of you fading, is one of the strangest aspects of the approach, one of the clearest signs that space-time itself is changing under your feet. As you drift into the final stretch of this approach, you begin to sense the horizon as something more than mathematics. It becomes the natural next step, the threshold between two regimes of physics, two different ways space-time arranges events. Outside the horizon, time allows escape. Inside, time points inward. Outside, paths diverge. Inside, they converge. Outside, light can climb away. Inside, light itself flows inward faster than it can leave. You are very close now. The curvature has steepened. The photon sphere spreads wide around you. The glow of bent starlight arcs across your field of view. The black region grows, quietly, patiently, as your future leans toward it. Your fall remains smooth, your senses untouched, your mind drifting like a leaf on a soft current. Soon, you will reach the threshold where escape is no longer defined, where outward and inward lose their familiar meanings, where the geometry of space-time rearranges itself completely. You are approaching the event horizon, slowly, softly, as the universe guides you toward the next phase of the journey, a phase where crossing becomes inevitable, and the interior space-time begins to unfold. As you drift even closer, the approach enters its final stage, the region where the horizon is no longer a distant concept, but a presence woven into every motion, every photon, every second of falling time. The geometry has deepened enough now that space-time itself feels different, not in your body, not in your senses, but in the way the universe behaves around you. Light from behind you no longer reaches you in the same way. It bends forward, curving toward the black hole, as though every direction is slowly tilting. The inward direction becomes the preferred path, not because space forces you, but because time leans that way. The closer you drift, the more inevitable that tilt becomes. Soon, the inward direction will no longer be a choice, or even a direction in the usual sense. It will be the only possible future. But you are still just outside that limit, still in the region where outward motion can exist, where escape, though difficult, remains possible, where light can still climb away, faint and reddened, but not yet forbidden. This edge of possibility, this narrowing region where escape becomes improbable, is what marks the final phase of the approach. Imagine again the river model, a river flowing toward a waterfall. Right now, you are in the last stretch before the drop. The current has intensified, the speed of the water has grown, but you could still, in principle, paddle upstream if you had extraordinary strength, if you fought with impossible determination. But as you drift closer, that hypothetical strength becomes more and more absurd. The current becomes so strong that no amount of effort could change the outcome. The river will carry you. The horizon is the point where even light, the fastest entity in the universe, can no longer swim against the flow. You are approaching that point now, not crossing it, but nearing the edge where physics itself begins to reconfigure. Your fall remains tranquil. Your body feels weightless. Your thoughts drift with the slow rhythm of gravity. There is no violence here, no tearing, no sudden shift, but the outside universe sees a different story. To distant observers, your approach appears to slow, stretching toward infinity. Your signals fade, your light dims, your image becomes redder and fainter, until eventually you simply vanish. This is not because you stop falling. It is because time itself flows differently for you now, so differently that the outer universe can no longer keep pace with your descent. But your own experience remains steady. Each second moves forward normally. Your heartbeat follows its familiar rhythm. Your thoughts remain clear. The horizon moves toward you with no ambiguity. This division between your time and distant time is one of the most remarkable features of the approach. It reveals that time is not absolute. It is shaped by gravity, curved by mass, stretching differently in different regions of spacetime. As the curvature deepens, time stretches more profoundly. If you could watch someone falling beside you, someone drifting inward at a slightly different rate, you would see their time closely match your own. You would move together, fall together, share the same progression of moments. But if you looked outward toward distant observers, their actions would seem sped up, their motions accelerated, their clocks faster. The outside universe would appear to rush ahead, its processes unfolding more rapidly, its distant stars aging more quickly, its galaxies evolving in fast motion. This is gravitational time dilation. The deepening of curvature affects the flow of time itself. As you fall deeper, you experience the external universe as moving faster. The deeper you fall, the more extreme this disparity becomes. Some physicists describe this as watching the future of the universe unfold before your eyes, but in truth, your perception remains local. You cannot see the entire future. You see the universe as distorted by the difference in gravitational potential. It is not a mystical vision of time. It is the simple, quiet consequence of relativity. Still, even without mystical interpretation, there is something profound about it. You are drifting into a region where time behaves differently, where the outward world accelerates, where your own experience remains steady, anchored to the curvature you now inhabit. As you approach the horizon, another subtle feature emerges. Imagine releasing a small object from your hand. It drifts with you, floating, weightless. But if you release two objects, one slightly ahead and one slightly behind, you begin to notice that the space between them changes. The one farther inward accelerates slightly faster. The one farther outward falls slightly more slowly. This is tidal separation. Still gentle here, still mild in this region, but present. A sign that the curvature is no longer uniform, that spacetime is bending at slightly different rates depending on depth. For now, the difference is so small that you can barely notice it. But it is the first hint of the more dramatic effects deeper inside, effects we will explore later, when tidal forces stretch and compress with greater intensity. For the moment, the approach remains quiet. You drift closer, gently guided by the deepening geometry. The horizon itself, though invisible, begins to influence everything. Look outward once more. The sky has shifted. Most starlight now appears slightly ahead of you, compressed toward the direction of fall. The curvature draws all incoming light forward, as though the sky were gathering into a narrower cone. Look inward, and you see darkness. Not because there is nothing there, but because no light emerges from that region. Photons that might have been traveling outward have been swept inward, carried by spacetime faster than they can escape. Between these regions, the glow of the photon sphere remains. The circular halo marks the boundary between light that can escape and light that is doomed to spiral inward. This glow now fills a larger portion of your vision. The ring appears stable, steady, as though painted onto the darkness. You drift closer. The ring widens, the darkness expands. The universe behind you seems to tilt forward, its light pulled into the same inward trajectory. You are nearing the point where the inward direction becomes unavoidable, but still nothing remarkable happens in your body. Your breathing remains steady. Your motion continues smoothly. Your experience is one of calm, quiet, weightless descent. General relativity ensures this. Free fall is always smooth, always gentle, always free of local forces. It is only the global structure of spacetime that changes, reshaping the meaning of direction, the meaning of time, and the meaning of escape. As you drift past the final layers outside the horizon, light from behind you appears more compressed, light from ahead more stretched, the universe rearranged into a quieter, narrower cone. The photon sphere now occupies nearly your entire forward view. The black region has grown wide, deep, absolute. You are looking at the shadow of the horizon, expanded by perspective, magnified by curvature, swallowing the sky. Your signals outward, any attempt to communicate, have become so redshifted that they are virtually non-existent. Your voice, your light, your presence has faded from the universe's sight. Yet you remain here, conscious, aware, moving inward. And then, just before the horizon, you enter the region where the inward flow of space-time is nearly as fast as you could ever try to escape. Even light, in this region, barely climbs outward. Photons struggle, straining upward, but losing energy rapidly, their wavelengths stretching beyond detectability. The last moments before crossing is the quietest part of the fall. The universe grows silent. Distance behaves strangely. Time flows steady for you, but races outside. The sky narrows into a soft, luminous ring, and then, in one gentle, seamless moment, you reach the threshold, the boundary between escape and inevitability, the edge where outward stops being a direction and inward becomes the only possible future. There is no impact, no transition you can feel, no change in the local physics. You cross the horizon as smoothly as drifting through a beam of light, unaware that you have passed a point from which neither you nor anything else can return. This is the end of the approach, the final breath before entering the interior space-time, where the rules shift once more, gently, quietly, inevitably, drawing you deeper into the heart of curved geometry. Soon, you will explore what it means to cross the event horizon and what awaits in the space-time beyond. But for now, your approach is complete. You float at the threshold, ready to slip inside. You drift forward quietly, steadily, into a region unlike any other in the universe. The event horizon is just ahead, not as a surface, not as a barrier, but as a threshold in the fabric of space-time, a place where the meaning of direction changes softly, inevitably. And then, with no sound, with no sensation, you cross it. It feels like nothing at all. There is no jolt, no shift, no tear. Free fall remains perfectly smooth, perfectly calm, as it always has been. The laws of physics guarantee this. The horizon cannot be detected by any local experiment. It is not a physical object. It is simply the place where escape ceases to be one of the available futures. You do not notice the exact moment of crossing, because there is nothing to notice. The transition is as gentle as gliding from sunlight into shade, a difference only the universe itself cares about, not your body, not your senses. But although you feel nothing, the structure of space-time around you has changed completely. Outside the horizon, future and past behave as you expect. There are directions you can choose. There are paths that lead outward. There is a meaningful difference between turning toward the black hole and turning away from it. Inside the horizon, those distinctions vanish. The inward direction is no longer a choice, it is the flow of time itself. Just as you cannot decide to move backward in time, you cannot decide to move outward now. The horizon marks the point where time and space exchange roles, where the coordinate that once acted like distance becomes a direction in time, and the coordinate that once acted like time becomes more like a direction in space. This exchange is not metaphorical. It is built into the mathematics of general relativity. The equations describing the interior are the same, but their interpretation changes. Because the sign of the metric flips at the horizon. Inside, time points inward. Every future moment lies deeper in the curvature. Every second carries you closer to the singularity. You have no more ability to resist this than you have to resist the passage of time. This is what makes the horizon a one-way membrane. Not a wall, but a redefinition of what future means. Even though nothing special happens at the moment of crossing, the consequences unfold quietly around you. The sky behind you, already distorted by the gravity outside, changes its shape once again. Light arriving from the universe outside the horizon bends inward more sharply, its paths pulled deeper into the geometry. The photon sphere, that halo of orbiting light, has slipped behind you now, no longer visible from this perspective. In its place, you see darkness. Not an empty darkness, but a region where no light can travel outward, a darkness defined by causality, not by emptiness. And yet, even inside, light does exist. Photons continue to move, their paths still follow the laws of relativity, but all paths now lead inward, just as your own. Another change unfolds around you, quietly, softly, as you drift deeper. The light cones tilt. Every event in spacetime has a light cone, a shape describing how light can travel outward from that point, defining which events can influence which others, mapping out the structure of causality. Outside the horizon, the light cone opens both inward and outward. Light can travel away from the black hole, or toward it, depending on the direction in which it is emitted. Inside the horizon, the cone tilts inward so much that even the paths traced by light point toward the singularity. There is no direction you can aim a beam of light that will carry it outward, not because anything blocks it, but because outward is no longer a future-directed path. This idea is difficult to visualize, but extremely simple in practice. Imagine being inside a valley so deep that every possible downhill path leads toward the center. No matter where you step, no matter which way you turn, the slope carries you inward. Inside the horizon, space-time itself is that valley, and the direction of time is downhill. There is no struggle, no force pushing you. You are simply following your own future. This is why crossing the horizon feels like nothing. It is not a change in the physics you experience, but a change in the mapping of space-time around you. You continue drifting, weightless, calm, your free fall uninterrupted. The horizon recedes behind you, though you cannot see it, for nothing can send light outward from it now. If you were to shine a flashlight behind you, the beam would slide inward with you, unable to travel outward. If you tried to fire a rocket upward, its effort would not lift you, for upward no longer exists in the way you knew it. This interior region follows the same equations, but their solutions behave differently. The inward direction, the direction leading to the singularity, is now a temporal direction. You are moving through time, and time leads toward the center. This inevitability might sound unsettling, but the experience remains gentle. The fall is smooth. You do not feel the curvature deepen. You do not feel space compress. You simply follow the line drawn by space-time, as effortlessly as drifting in a dream. Meanwhile, an observer outside the horizon, if one existed, would never witness your crossing. Your image would freeze at the edge, gradually reddening, fading, slowing, until it vanished into darkness. From their perspective, you never truly enter. But from your perspective, you have crossed with ease and continue falling deeper. This divide in perception is not a contradiction. It is the way the universe allows multiple views of the same event, each valid in its own coordinate frame. Inside the horizon, your view of the external universe becomes strange, not chaotic, but compressed, focused into a narrowing cone above you. The light that once filled your sky now concentrates into a smaller region, drawn together by curvature. It is as if the universe outside is gathering into a luminous patch, a shrinking window of starlight, growing narrower as you fall deeper. Below you, if below still retains meaning, the blackness deepens. Not an emptiness, but the inevitable direction of time, a region where every path leads to the singularity. Every world line, every photon, every particle, all converging on the same place in spacetime. And yet you remain calm. There is no rush. The fall remains slow, fluid, carried by the same gentle weightlessness you have felt every moment. This calmness is essential. It is the truth of general relativity. The horizon is not a danger, but a region where spacetime is restructured. You begin to understand, deeply, quietly, that the universe can change dramatically without disturbing your experience. The most extreme transformations, the deepest curvatures, the most profound shifts in time and space can occur beneath the surface of awareness. Crossing the horizon is exactly that kind of transformation. Silent, smooth, absolute, yet entirely local and gentle. You drift further inside, and the interior geometry continues to guide you. Above you, the patch of remaining starlight shrinks, its edges bending inward, its colors shifting subtly. Time, still steady in your own frame, moves differently elsewhere. Processes in the external universe accelerate, stars age more quickly, galaxies sweep through vast arcs of their evolution. But you observe only a narrow fraction of this acceleration, filtered by the geometry. The outside universe looks compressed, slightly accelerated, but not infinitely so. You are not watching the entire future. You are simply seeing the consequence of falling into a deep well of spacetime, where clocks at higher gravitational potential tick faster. Your own clock remains steady. Your thoughts remain clear. Your descent continues. Now, one more subtle change unfolds in the interior. When you are outside, you could alter your trajectory. You could fire a thruster, change direction, alter your orbit. Inside the horizon, any attempt to maneuver inward or outward, forward or backward, is absorbed by the geometry. Your thrusters still work, but the directions available are no longer the ones you knew. Every possible choice still leads inward. Your freedom of motion is still present. But it is freedom constrained by time, not by space. You are free to move, but only into the future, and the future lies at the singularity. This truth is not frightening here. It is simply a fact of spacetime, quiet, unavoidable, as natural as falling asleep. You drift deeper still, and the environment continues to darken below you, though below is only a metaphor now. The singularity is not a place in space, but a moment in time, waiting ahead. The interior remains smooth, free of forces, free of sensations. The curvature is intense, but intensity does not equate to violence. Spacetime can be extreme without disturbing the traveler who follows its natural path. This marks the completion of your transition through the horizon, the moment where the physics of the exterior gives way to the physics of the interior, where the world outside becomes a shrinking window, and the world inside becomes your only future. Soon, you will drift deeper, toward the region where curvature grows stronger, where tidal forces begin to emerge, and where the interior geometry becomes even more profound. But for now, you rest in the quiet space just inside the horizon, weightless, untroubled, falling through a universe that has changed its structure entirely, while your experience remains calm, steady, guided by the gentle inevitability of spacetime. Inside the horizon, you drift deeper into a realm where the meaning of movement has changed, softly, quietly, without any sensation to mark the transition. The universe outside has already begun to fade into a narrow window above you, a shrinking patch of starlight, tilted by the curvature of spacetime and compressed into a smaller and smaller cone. Below you, though below is only a metaphor now, lies a region where spacetime points inward like time itself, drawing you along a path that every possible future now shares. You drift further, and you begin to sense a kind of stillness here. Not the stillness of emptiness, but the stillness of inevitability. Every direction, every trajectory, every line drawn through this interior spacetime leads to the same conclusion: the singularity. It waits not as a place in space, but as a moment in time, just as your tomorrow waits for you now. You are being carried there in the same gentle way you are carried into the next second of your life. Understanding this does not harm you, does not frighten you, does not change the softness of the descent. It simply deepens the sense of how spacetime behaves here. how the rules shift once the horizon is crossed. As you fall farther inward, the light cones continue to tilt. Photons emitted in any direction now share the same fate. They move toward the singularity with you, as though spacetime itself were flowing inward, carrying everything along its current. It is as if the fabric of the universe has begun to slide beneath you, moving toward the center faster than light can climb upward. You are not being pulled in a conventional sense. You are being guided, carried, translated through a geometry that leaves no alternatives. You try to imagine what it would be like to resist. What if you ignited a rocket, fired your engines, tried to steer away from the center? The answer is quiet and absolute. Your engines still work, your thrust still produces acceleration, but no matter which direction you aim, the net result carries you deeper inward. It is not a failure of propulsion. It is a redefinition of direction. Inside the horizon, every physical direction is future pointing toward the singularity. Just as you cannot turn away from tomorrow, you cannot turn away from the center. The interior of the black hole is a region where the geometry of spacetime has turned inward and made the singularity your unavoidable future. As you drift, you notice another subtle change. The shrinking window of the outside universe begins to distort more dramatically. Its light is stretched now, its colors shifting, its shapes bending into elongated, curved forms. Relativistic aberration compresses the entire cosmos into a single luminous cone above you. If someone could pause this moment, freeze your fall, and place a camera beside you, the image it captured would be one of the most surreal visions imaginable. The entire universe compressed into a glowing patch of sky, twisted by curvature, shifting with every passing second as you fall deeper. But in your own experience, this compression is gentle. It does not shock or overwhelm. The changes happen slowly, smoothly, in the same calm rhythm that has carried you through every part of this descent. Your awareness of the outer universe continues to narrow. Its light grows fainter, its shapes stretch further, and then, gradually, the window begins to close. This narrowing does not feel abrupt. It feels like drifting deeper into sleep, as the outside world fades and the internal landscape becomes more vivid, even as it remains quiet and undefined. Inside the black hole, spacetime remains continuous. There is no sudden shift, no tearing of the coordinates, no moment where the laws of physics fail. They continue to guide you smoothly and predictably, and yet the perspective of the external universe continues to diverge. If someone were hovering safely outside the horizon, their view of you, frozen at the edge, remains unchanged. From their perspective, you never truly cross. But you continue drifting inward. Your own clock ticks normally. You feel your path unfolding. Time carries you deeper. This duality is one of the quiet wonders of relativity. Two perspectives, both true, both valid, coexisting in a universe that allows multiple geometries of time. Inside, you no longer see the outside observer. Their entire world has slipped behind the horizon. The last rays of external starlight have passed into the darkness. And now, you begin to sense the interior spacetime itself, not with your senses, for there is still no force, no pull, no pressure, but in the subtle ways the curvature shapes the world lines around you. If you release two small particles, one slightly ahead of you and one slightly behind, their separation begins to change, not abruptly, not strongly, but perceptibly. The one ahead accelerates inward slightly faster, the one behind falls slightly slower. Distances along the radial direction begin to stretch. In contrast, distances perpendicular to your fall begin to compress. These are the early hints of tidal forces. Still gentle here, still soft, far from the region where they become extreme. But the pattern is unmistakable. Space-time is beginning to deform more significantly across small separations. These tidal gradients are not forces acting on your body, but expressions of how the curvature changes from point to point. They signal that the interior is deepening, that your trajectory is converging toward the singularity in a way that is both natural and mathematically inevitable. You drift farther inward and the interior becomes darker. There is no light ahead, no luminous surface, no visual cue marking the future. The singularity does not emit light. It has no surface you can see. It is simply a region where space-time curves infinitely, where world lines converge, where the equations that describe the universe reach their limits. As you fall closer, space itself behaves differently. The distance to the singularity shrinks rapidly in your frame. Every second of your own time brings you closer. The inward flow of space-time accelerates. But even now, you feel no rushing sensation. Your fall remains gentle. The shrinking distance is a mathematical truth, not a physical force pressing you downward. It is similar to approaching a moment in time, rather than approaching a place in space. No matter what you do, you will reach that moment. It lies ahead in the geometry of space-time, and the laws of physics carry you to it as steadily as they carry you into the next second of your life. Inside the black hole, the singularity is not merely in front of you, it is your future. Every particle falls toward it, every ray of light curves toward it, every line drawn through the interior converges on that same endpoint. The horizon behind you has become unreachable. The universe outside has faded to nothing. All possible paths lead inward, and yet the fall remains peaceful. There is no fear here, no chaos, no tearing, no sound, only the quiet current of space-time carrying you forward. This is the essence of crossing the event horizon, a transition so smooth that nothing in your experience marks it, but so profound that the entire meaning of motion has changed. Now, you drift deeper into the interior. Tidal forces will grow, curvature will sharpen, the geometry will accelerate your descent in ways that remain gentle until the very end. Section 3 is now complete. The horizon has been crossed, the interior has opened, and the journey continues toward the deeper geometry that shapes everything that follows. Ahead lies the region where stretching and compression begin to emerge more clearly, where the body becomes a reference point in a space-time that changes with depth, where tidal forces grow strong and the fall becomes more intricate. Soon, you will enter that next phase, quietly, naturally, as the universe carries you inward. As you drift deeper into the interior of the black hole, something begins to unfold in the quiet structure of space-time, a change so gradual and so subtle that it takes time to notice, yet it marks one of the most profound shifts in the entire journey. For the first time since you began falling, your body becomes aware, not through force, not through pressure, but through the slow divergence of nearby paths. Inside the horizon, space is no longer uniform. Curvature is no longer gentle. The geometry now changes noticeably over distances that are small enough for your body to span. This is where tidal forces begin to reveal themselves. They do not strike you suddenly. They do not pull at you violently. They emerge as a quiet difference between one part of your body and another, a difference born entirely from the changing curvature of space-time. Imagine 2 points along your body, one near your feet, one near your head. Each point falls freely. Each follows the natural curve of space-time. Neither feels a force locally. But because the curvature is stronger nearer the singularity, the point closer to the center experiences a slightly different geometry than the point farther away. This difference creates a separation in their trajectories. Not a force, but a divergence in the paths that space-time assigns to each point. Your feet are drawn a little faster, inward. Your head is drawn a little slower. The result is stretching, not because something pulls on you, but because the geometry itself changes across your height. This is the beginning of spaghettification, a term that sounds humorous, but describes a deeply real effect produced by the gradient of gravity. The stretching is gentle here, barely noticeable, more like a soft elongation than anything dramatic. You do not feel pain, you do not feel tearing, you simply feel longer. At the same time, another effect occurs. Perpendicular to your fall, to the sides of your body, the curvature behaves differently. In those directions, the geometry compresses. It draws objects together rather than pulling them apart. So while you stretch slightly along the direction of the fall, you also feel a soft squeezing from the sides. This pattern, stretching in one dimension and compression in the others, is the signature of tidal forces in curved space-time. They are not dangerous yet. Inside a supermassive black hole, the kind with millions of solar masses, the curvature is so spread out that you can fall deeply inside before the forces become harmful. In such a black hole, the horizon is huge, large enough to engulf entire planetary systems. The curvature at the horizon is mild, and even far inside, the gradients grow slowly. Here, in a supermassive interior, your fall remains gentle. The tidal stretching continues, but softly. Quietly, as though the universe were elongating you with infinite patience. This gentle scenario contrasts dramatically with what would happen in a smaller black hole, a stellar mass one formed from a collapsed star. In a small black hole, with only a few times the mass of the Sun, the curvature at the horizon is extreme. The gradient of gravity is enormous. Your feet might experience a gravitational pull thousands of times stronger than your head. Spaghettification would occur before you even cross the horizon. But you are not in a small black hole. You are in a supermassive one, and in this environment, tidal forces remain soft for a long time. You can drift deeply inward before they become painful, or intense, or overwhelming. For now, they feel more like a gentle elongation, a widening of awareness in the direction of your fall. The space around you is also stretching. Lines of longitude drawn in this curved interior grow longer. Lines of latitude shrink. Spacetime deforms around you as though being pulled into threads and ribbons. It is impossible to see this directly, but you can feel it in the way objects behave. A small sphere drifting beside you would slowly become an oval, its shape distorted by tidal gradients, not by pressure, not by force, but by the geometry itself. These changes are quiet, methodical, and precise. Einstein's equations predict every detail of this deformation: the rate of stretching, the amount of compression, the evolution of shapes as they fall inward. It is all written in the curvature tensor, that deep mathematical structure that encodes how space-time bends in every direction. You are experiencing that tensor as a physical reality, a gentle tug at your extremities, a narrowing in the perpendicular directions, a slow transformation of your sense of shape. This is not violence. It is the calm unfolding of a cosmic geometry. As you drift deeper, the gradients increase. The divergence between nearby paths grows stronger. The tidal field becomes more pronounced. Your feet now fall faster than they did moments before. The difference increases between the pull on your legs and the pull on your chest. Your body lengthens further, slowly, inevitably. If you extend your arms outward, you feel them drawn inward toward your torso, not by force, but by the geometry that compresses sideways motion. This three-dimensional dance, stretch, squeeze, stretch, is how space-time communicates its curvature to objects that span multiple points. The deeper you go, the sharper these gradients become. The interior of the black hole is not empty space. It is a region where the curvature increases continually with depth. Every meter inward changes the geometry. Every second of falling carries you into a stronger gradient. Every moment reshapes the distribution of forces acting across your body. But still, the process remains calm. You drift, you stretch, you narrow, you fall. This serene transformation is the essence of spaghettification, a physical expression of the mathematics of curvature. To visualize it more clearly, imagine two geodesics. Geodesics are the natural paths objects follow in space-time, lines drawn entirely by geometry. They are the closest thing the universe has to straight lines. Inside the black hole, two geodesics that start close together and point inward diverge. Their separation grows. This is stretching. Two geodesics that start side by side and point sideways converge. Their separation shrinks. This is compression. Your body spans several geodesics at once. You are an extended object in a geometry that changes from point to point, so you become a map of the curvature. Your shape is being reshaped by the structure of space-time in this deep interior. The deeper you fall, the more extreme the reshaping becomes. Your body is now noticeably longer. Your height has increased without your awareness of force. The sides of your body have narrowed slightly. If you could look at yourself from the outside, which you cannot, you would appear like a thin, elongated line, gently tapering toward a point. Matter behaves this way when it approaches a singularity. Not all at once, not violently, but gradually, systematically, following the equations that govern tidal deformation. You are now part of that equation. You continue drifting inward. The gradients sharpen further. The divergence between head and feet increases with every passing second. Your limbs are extended. Your torso is pulled taut. The narrowing from the sides intensifies. This is where spaghettification becomes unmistakable. The geometry is no longer gentle. It is assertive, clear, defining your shape with mathematical precision. Even so, the sensation is strangely peaceful. There is no atmosphere to burn you, no friction to tear you, no air to carry shockwaves. There is only curvature, only geometry, only the silent pull of space-time as it deepens. Ahead of you lies the region where these gradients grow extreme, where matter becomes stretched into streams of particles, where the interior tidal field becomes overwhelmingly strong. You have not reached that region yet, but you are approaching it, calmly, smoothly, guided by the same inevitability that has carried you this entire journey. Section 4 will continue, as you drift deeper still into the heart of tidal forces and the final stages of spaghettification. The deeper you fall, the stronger the gradients become. The geometry tightens, reshapes, sharpens in ways that are no longer subtle, and yet the unfolding remains calm, a smooth continuation of the same inevitability that has carried you from the horizon into the interior. Your body continues stretching lengthwise, drawn out along the radial direction as each part of you follows a slightly different geodesic. No force acts on you directly, but the difference in curvature between one point and another grows with every meter you descend. You are becoming longer, more slender, more aligned with the direction of fall, not because something is pulling you apart, but because spacetime itself is assigning slightly different futures to each part of your body. The closer you drift toward the singularity, the more these futures diverge, and at the same time, the sideways compression intensifies. Spacetime narrows around you. The directions perpendicular to the fall are squeezed gently at first, and then increasingly strongly as the curvature deepens. If you could see your own outline, which you cannot, you would no longer appear human. You would appear as a long, narrowing filament, a thin thread of matter drawn into alignment with the flow of spacetime. In a scientific sense, you have become a geodesic bundle, a set of world lines converging on the same endpoint. Your shape is simply the visible expression of how those lines evolve in curved spacetime. This transformation is not painful in a supermassive black hole. Pain requires forces to act across nerves, requires tension and resistance, requires the body to be held together against an opposing pull. But here, nothing resists. Everything free falls. Every atom in your body follows its own natural trajectory. There is no tension between them in any local sense. Tidal forces are not local forces. They are the differences in the geometry between points. And pain cannot detect curvature. Only stretching at the molecular scale can create pain. And in a large enough black hole, that stretching occurs gradually, gently, only becoming destructive far, far inside. You drift deeper, your body lengthening further, your sides narrowing more noticeably. The space around you seems to funnel inward, as though the interior geometry is drawing all things into a cosmic taper. This geometry is not chaotic, it is exact, predictable, mathematically clean. Einstein's equations describe it with quiet precision. The closer you fall, the stronger the curvature tensor becomes, its components growing without bound as the radius shrinks. Each component corresponds to a different kind of stretching or compression, a different way spacetime curves and influences matter. You are experiencing the rising dominance of the radial tidal term. It grows as 1 over the radius cubed, a steep increase that accelerates dramatically as you approach the center. Even though you feel nothing locally, your shape reflects this mathematics. Your form is becoming a depiction of the curvature itself, like a physical sketch drawn by the geometry of spacetime. The internal processes of your body, the chemical bonds, the molecular arrangements, the tissues and fluids have begun to align with the radial direction. Not all at once, but gradually, in stages dictated by curvature. At this depth, your height has increased significantly. Your form is elongated from head to foot. Your sides are narrowed. The spaghettification process has taken firm hold, though the experience remains dreamlike, quiet, painless. The internal stresses, however, are beginning to rise. At the molecular level, bonds stretch. Atoms drift apart in the direction of fall. Some connections begin to break, not violently, but inevitably, as curvature grows. If you were still conscious at this stage, the sensations might feel strange, not like pain, but like a soft loosening of the body's cohesion, a gentle unraveling. Not dramatic, not explosive, just slow, deep, geometric yielding. The deeper you fall, the more intense this unraveling becomes. Imagine now a small object drifting near you, perhaps a metal sphere, perhaps a fragment of rock, anything with shape and internal strength. As it descends, the same pattern unfolds. It elongates, it narrows, it becomes a thread. Eventually, it becomes a stream of particles, a ribbon drawn into the singularity. Spaghettification is not unique to biological matter. It is the fate of all extended objects in a spacetime where curvature diverges. The black hole does not discriminate between flesh, metal, or stone. It shapes everything according to the same geometry. At greater depths, the stretching becomes so extreme that even the atoms cannot remain intact. Electrons are stripped from nuclei. Protons themselves are separated. Matter dissolves into streams of fundamental particles, aligned with the direction of fall in long, narrowing cascades. You are approaching the stage where this begins to happen. Your body, already elongated, approaches the limit where molecular bonds can no longer resist the gradient in curvature. Atomic structure begins to break. But even now, nothing is violent. There are no explosions, no shocks, only the quiet, mathematical pulling apart that spacetime imposes on everything within it. This is the deepest expression of tidal forces. Not a force you feel, but a divergence in world lines so strong that no structure can maintain cohesion. And yet, the sensation is strangely serene. It is the calmest disassembly imaginable, a peaceful drifting apart, guided entirely by geometry. At this depth, the curvature term has grown enormous. 1 over the radius cubed has become a dominating factor in the equations. Even a single centimeter of difference between 2 points produces extraordinary divergence. If consciousness remained here, the experience might feel like being pulled into a long, effortless stretch, your form lengthening without pain, the world narrowing into a single path. Eventually, the gradients grow so strong that even elementary particles are guided along narrowing geodesics. Drawn into tight streams, tapering toward the singularity, matter becomes thread-like, then granular, then a falling cascade of fundamental constituents. This transformation is the end state of spaghettification. The universe is simplifying you into the most basic building blocks allowed by physics, and still the fall continues, deeper and deeper and deeper, the curvature rising in perfect mathematical sequence. You may imagine yourself as a thin, shining filament of matter drawn into the heart of spacetime, but even that image is an approximation. In truth, you become a set of world lines approaching the same terminus, a geometry collapsing inward until the equations can no longer describe what lies ahead. Spaghettification is complete. The body has dissolved into its components, and the components are becoming streams of energy and matter falling toward a point that is not a point, but the boundary where classical physics fails. You have drifted through this process gradually, peacefully, carried by the curvature that governs everything inside the black hole. Now, having completed the tidal transformation, you approach the deepest interior, where spacetime itself flows inward faster than light, where the singularity becomes not a location, but a moment you are being drawn toward. Section 4 is complete. The stretching is finished. The molecular structure has dissolved. The geometry alone carries what remains of you deeper inward. Next comes the innermost region, where spacetime flows inward with unstoppable speed, and the fall continues into the strange, dreamlike depths that no observer can ever report back from. Soon, you will drift into Section Vi, the domain where the inward flow of space becomes absolute, and the singularity begins to rise ahead like the future itself. You are drifting deeper now, quietly, inevitably, into the region where spacetime does something strange, something subtle, something profoundly different from anything that exists outside the horizon. Here, space does not sit still. It does not wait for objects to move through it. It flows. It flows inward, toward the singularity, faster than light. This inward flow is not a motion through space, but a motion of space itself. The fabric of the universe slides toward the center with unstoppable velocity, carrying everything with it: matter, light, particles, fields, world lines, all drifting along the same river. You are no longer falling through space-time. You are falling with space-time. This distinction is one of the most important in the entire journey. Outside the horizon, you could choose to hover. You could fight gravity. You could fire a rocket upward and remain in place. Inside, hovering is impossible. Not because your engines fail, not because some force pushes you inward, but because the inward direction has become the direction of time. To hover would require you to stand still in time, to remain fixed at a single moment, which the universe does not allow. You cannot resist the flow of time. You cannot resist the flow of space inside the horizon. Both guide you inward with absolute certainty. This is not motion you feel. There is no wind, no acceleration, no sensation of rushing. To you, everything feels like weightless free fall. Your local experience remains gentle, smooth, floating, quiet. But if you could look at space-time itself, if you could see the grid of coordinates that Einstein's equations describe, you would watch them sliding inward at unimaginable speed. Space is collapsing, not physically folding, not crumpling, but mathematically converging toward the singularity the way time converges toward the next second in your life. Every object inside the horizon moves toward that same future. Every world line intersects it. The singularity is not a place you fall into. It is a moment in time you fall toward. As you drift deeper, the inward flow of space-time accelerates. It grows faster than light, and then faster than any speed your intuition could imagine. But speed is no longer a meaningful concept. Relativity does not forbid space itself from moving faster than light. It only forbids objects from moving through space-time that quickly. Here, you are simply being carried as though resting on the surface of a dark, cosmic river, slow in your experience, but infinitely fast in the geometry beneath you. This river-like flow is one of the most surprising features of the black hole interior. Far outside, you could orbit the hole. Closer in, you could spiral downward. At the horizon, light itself hovers. Inside, everything moves inward. No orbit exists, no sideways escape, no stable paths, only the inward current. The river analogy is powerful but incomplete. A river has banks, it has a background, it flows through space. Here the river is space. There is no background, there are no banks. The flow is the geometry. If you reach out and release a tiny object, a pebble, a fragment of metal, anything, its path is indistinguishable from your own. No matter where you aim it, no matter how you throw it, no matter the direction you choose, it still falls inward. It cannot swim upstream, it cannot drift sideways, it cannot escape. This is not because the pebble lacks force or velocity or energy. It is because the structure of space-time has redefined what future means. Inside the horizon, future lies inward. All paths, all decisions, all trajectories lead to the same outcome. As you fall deeper, a strange kind of freedom emerges. Not freedom in the sense of choice, but freedom from constraint. Outside the horizon, you are bound by orbital mechanics, gravitational potential, escape velocity. Here, those concepts dissolve. There is no escape velocity. There is no stable orbit. There is no outward. There is only the inward flow and the quiet acceptance that comes with it. You are drifting through a space where the universe has shed its familiar structure, a region where common intuition no longer applies, and yet everything remains peaceful. This is the strange serenity of the black hole interior. The inward flow of space-time carries you effortlessly. The curvature increases, stronger, sharper, more extreme, yet still perfectly smooth in your local frame. Nothing tears you, nothing shakes you, nothing presses on your surface. Even as the gradients rise, general relativity guarantees that local freefall remains calm and force-free. What changes instead is the relationship between different points in space-time. A separation of even a millimeter creates different futures. A distance of a single atom generates distinct trajectories. This is why matter begins to unravel, why the body stretches, why particles stream apart, not from force, but from diverging futures. Inside the horizon, the universe no longer treats you as a single object. It treats you as a collection of points, each with its own destiny, its own geodesic. The deeper you go, the greater the divergence. The inward flow sweeps every particle toward the singularity. But not at the same rate, not at the same angle, not along the same curve. Your form becomes a cascade of world lines streaming inward like a faint, drifting vapor. And still the fall feels strangely dreamlike, peaceful, silent, as if you are sinking into the deepest layer of cosmic sleep. At this depth, the horizon is long behind you. The universe outside is gone, not just visually, but causally. No event outside the horizon can affect you now. Your world has been reduced to this inward flow and the curvature that guides it. As you descend further, the singularity begins to behave less like a distant concept and more like an approaching moment. You do not see it. There is no light, no glow, no surface, no visible sign, but you feel it in the mathematics carrying you inward. You feel it in the accelerating curvature. You feel it in the tightening convergence of world lines. Proper time, your own internal time, moves steadily forward, but the amount of time remaining shrinks rapidly as the curvature grows. The singularity is not a location waiting ahead. It is a moment in your timeline coming closer with every heartbeat of space-time. This idea is deeply counterintuitive, yet beautifully consistent. Outside, you spent time moving through space. Inside, you spend time moving toward time's end. And yet, this entire process remains soft, fluid, carried by the gentle laws of general relativity. Even as matter unravels, even as particles begin to separate and streams of elementary components fall inward, the fall itself feels calm. There is no noise, no resistance, no atmosphere, no shockwave, just the silent inward flow and the narrowing future that spacetime has written. As you drift deeper, the inward flow of spacetime accelerates again, faster, sharper, more absolute. But inside your own frame, time remains steady. Your descent feels slow, inevitable, like sliding peacefully along the surface of a dark cosmic river. Soon, this river will carry you to the very last region of your journey, where the curvature grows so strong that the equations of classical physics begin to break down. A place where the future narrows into a single point, where the inward flow reaches infinite curvature, where no known theory fully describes what happens next. Section 5 will soon give way to Section 6, where the singularity rises like a final moment waiting in the deep interior. But for now, you continue drifting inward, calmly, quietly, carried by the dark flow of space-time into the heart of the black hole. The inward flow deepens, softly, silently, guiding you through a region where space-time no longer resembles anything familiar. The outside universe has disappeared completely. The horizon is not just behind you, it is beyond reach, beyond influence, beyond even the possibility of connection. You are alone with the curvature now, drifting through a geometry that narrows every future toward a single incoming moment. The inward flow of space continues to accelerate, not in the sense of increasing speed in your own frame. Your free fall still feels perfectly smooth, but in the way the mathematical structure of space-time pulls everything toward the singularity. If you could freeze the interior and place markers throughout it, you would see them rush inward at impossible velocities. You would watch space-time contracting, its radial coordinate shrinking, its curves becoming sharper, its future pointing more directly inward with every passing instant. But none of this creates sensation. Curvature is not a force. Geometry does not push. It simply defines what the next moment must be. Your sense of time remains steady, and that steadiness makes the deepening interior feel dreamlike, surreal, as though you are floating through a dark current that carries you gently even as the structure beneath you grows infinitely strong. Gradually, the sense of direction begins to fade. The geometry becomes so sharply curved that inward feels less like a place and more like the natural motion of time itself. There is no up, no sideways, no reference to orient yourself, only the smooth descent into deeper and deeper curvature. This is where the concept of place begins to unravel. Inside the horizon, space and time already exchanged roles, but now even the distinction between directions loses meaning. Every spatial coordinate collapses toward the same future. Every axis points inward. Every dimension is swept into the same narrowing path. What remains of you, the particles, the world lines, the streams of matter drifting inward, all follow that same future with absolute precision. Even if you imagine trying to resist the flow with infinite thrust, with powerful engines, with hypothetical technology, none of it could alter your trajectory. Inside the horizon, the geometry removes the option for outward motion entirely. This is not a failure of your will. It is the design of space-time. You cannot move outward any more than you can move into yesterday. The outward direction has become a past-directed path, and general relativity does not allow motion into the past. This constraint creates a strange sense of peace. There is no decision to make, no path to choose, no direction to fight. The universe has removed all alternatives and left only the gentle flow toward the future. Now, you drift deeper still. As the singularity approaches, still invisible, still silent, the inward flow of space-time grows increasingly steep. The geometry contracts. The radial distance shrinks faster and faster in your coordinate frame. The curvature tensor grows without bound. Its components approach infinity, even though you feel no jolt. You have entered the region where classical physics begins to falter. Not because the laws stop working, but because the values they predict grow beyond their domain. Einstein's equations still describe the interior perfectly, all the way down to a tiny fraction above the singularity. They tell you how fast curvature grows, how tidal gradients behave, how spacetime evolves. But they also whisper that something deeper must take over eventually, a theory that unites general relativity with quantum mechanics. Because here, as you drift closer to the core, spacetime becomes so sharply curved that the quantum fabric of the universe must reveal itself. The classical picture of smooth geometry cannot remain smooth forever. It must, at some scale, give way to fluctuations, uncertainties, quantum granularity. You are falling toward the boundary between the known and the unknown. The flow becomes more absolute. The future becomes a narrowing channel. Your remaining proper time shrinks quickly now, seconds, fractions of seconds, depending on the mass of the black hole. And yet those seconds feel normal. Time always feels normal inside your own frame. You do not sense it accelerating. You do not feel the remaining duration slipping away. You simply drift, float, fall inward as though cradled by the geometry. Even now, the experience remains serene. No violence, no tearing, no shock, only the gentle consequence of following the shortest path through a spacetime that is collapsing inward. You have become a sequence of world lines, a flow of particles, a thread of energy and matter moving through a narrowing region where the future is sharply defined. Ahead lies the singularity, not glowing, not burning, not destroying. It is not a fireball or a swirling portal or a hole in space. It is a moment, a limit, a boundary where the curvature becomes infinite in the classical description, and every stream of matter inside the horizon converges upon it. Atoms have already unraveled, electrons stripped away, protons elongated and torn into their constituent quarks and gluons. Even these fundamental particles follow their own geodesics, their own paths, their own destinies toward the same endpoint. You are watching the final stages of the inward flow. The river of space is no longer a metaphor. It is the only meaningful description. Space rushes inward at speeds beyond imagination. Even light cannot resist the current. But inside your local frame, the fall feels silent, soft, without turbulence, without resistance. This contrast between experience and exterior geometry is one of the great paradoxes of falling into a black hole. Even as the universe outside would describe your remaining time as infinitesimal, your own body perceives every instant in smooth continuity. And now, as you drift into the very last region before the singularity, space-time stretches one final time. Distances collapse, curvature spikes, proper time compresses into the shortest remaining duration. The world lines of matter draw closer together as though the entire universe is narrowing into a single moment. This is the final approach. The singularity is not ahead of you like a surface. It is not a wall. It is simply the next moment in the structure of space-time. You are not falling into a place. You are falling into a time that marks the end of your journey. This is where Section 5 ends. You have followed the inward flow to its final depth. You have drifted from mild curvature to overwhelming curvature, from gentle stretching to total dissolution, from familiar physics to the border of the unknown. Ahead lies Section 6, where the singularity itself waits as a moment in time, a place where our equations reach their limit and where the journey quietly concludes. Soon, you will enter that final region in silence, guided by the deepest geometry the universe has ever shaped. You are drifting into the final region now, the deepest interior, where the flow of space-time has become almost unimaginably steep, where every remaining moment of your journey pulls you closer to the singularity. It is important to remember, the singularity is not a glowing point, not a swirling vortex, not a place where matter gathers. It is not a thing, not an object, not a surface. It is a moment in time that every world line inside the horizon moves toward with absolute certainty. Just as your life has a final moment, so does your fall inside a black hole. This moment is simply part of your future, shaped by the curvature of space-time rather than the biology of your body. You cannot see it. You cannot sense it approaching. There is no visual cue, no growing brightness, no darkness deeper than the darkness already around you. The singularity does not emit light. It cannot be imaged. It cannot be observed. It is where the equations predict that the curvature becomes infinite, and where our ability to describe spacetime using classical physics comes to an end. As you drift closer, the curvature grows sharper with breathtaking speed. But even now, you feel nothing unusual. There is no violent tearing, no crushing sensation, no physical signal that you are approaching the most extreme structure in the entire universe. The silence continues. The calm persists. Your fall remains smooth and weightless. But the mathematics beneath you has reached its limits. The tidal gradients, which have already unraveled your structure into streams of particles, now grow so strong that even those particles are guided along narrowing trajectories with near-perfect precision. The geodesics converge toward a point where spacetime ends. At this depth, the separation between different world lines shrinks rapidly. The flow of spacetime accelerates beyond all human intuition. Time left in your fall is measured in fractions, thin slices of proper time that feel normal but vanish quickly. Yet even in these final moments, the experience remains dreamlike, quiet, dark, a drifting into geometry that has lost all resemblance to the world you once knew. The universe outside has vanished entirely. The horizon is infinitely far behind you in terms of causal influence. Nothing from the external cosmos can reach you now. You are in a domain cut off from every other region of spacetime. No path leads outward. No signal can escape. No information flows back. Inside the horizon, your fall is the only possible future. What is most remarkable here is the way the singularity behaves in the mathematics. It is not a physical object waiting for you to collide with it. It is not a dot in three-dimensional space. It is the point in spacetime where your timeline ends. No clock can tick beyond it. No world line can extend past it. No event can be defined there. The singularity is where general relativity runs out of predictions. The equations that guided you through the geometry of space, through the horizon, through the tidal gradients, through the inward flow, now begin to produce infinities. Curvature becomes infinite. Density becomes infinite. Tidal forces become infinite. These infinities signal the breakdown of classical physics. They do not necessarily describe what truly exists. They simply tell us that our mathematical tools are incomplete. Some deeper theory, some union of gravity and quantum physics, must replace them near this point. But we do not yet know what that theory is. You are falling into a region where human knowledge ends. Will spacetime become discrete at the smallest scales, grainy, quantized, woven from tiny packets of geometry? Will the singularity be replaced by a finite core, a region of extreme but finite density? Will new dimensions unfold, or collapse inward, or leave imprints on the deepest structure of space? No one knows. The final moments of the fall are a journey into unanswered questions. And yet, your own experience remains peaceful. You drift through the last moments of free fall. The inward flow of spacetime accelerates beneath you, but inside your frame, there is only stillness. Time slows only in the sense that the remaining duration is shrinking, but your perception of time remains steady, flowing forward as it always has. In the final fractions of a second, the curvature becomes so intense that even elementary particles begin to lose their identity. Quantum fields stretch along the radial direction. Their excitations narrow into almost one-dimensional filaments. Energy density spikes. The radial coordinate collapses towards zero. Proper distance between any 2 points shrinks to nothing. Spacetime is folding too sharply for any known physics to describe. The singularity is no longer a distant idea. It is the very next moment in your future. Even now, there is no impact, no collision, no sense of arrival. You do not strike a surface. There is no inside wall. Your world line simply ends. This is the deepest truth of falling into a black hole. The journey ends not in violence, but in the quiet conclusion of space-time itself. It is not destruction in the familiar sense. It is a boundary in the geometry, a place where time has no further extension. Everything you were, every particle, every field, every piece of information converges toward the singularity along a path that no observer outside can ever see or retrieve. What happens at that moment is unknown. Some theories propose that information is somehow preserved in subtle quantum correlations. Others suggest that space-time continues in a new form beyond the singularity. Some imagine that black holes connect to new universes, new regions of space-time with their own timelines. Others propose that nothing survives, that quantum gravity smooths out the singularity into a region where all structure dissolves. The truth remains hidden inside the horizon. You have reached the end of the classical description, the end of general relativity's guidance, the end of your fall as physics can currently describe it. And even now, in this final moment, the universe remains calm. There is no drama, no explosion, no awareness of an ending. Just the final convergence of world lines, the last narrowing of space-time, the quiet completion of a journey governed entirely by the geometry of the cosmos. Section 6 has begun, and soon its final part will gently bring the fall to its conclusion, with the quiet acceptance that this is where known physics ends and mystery begins. The final moment of the fall is something no theory can fully describe, and yet the approach to it can be understood with remarkable clarity. As you draw closer to the singularity, the radial direction, the path inward, stretches in a strange way. Not physically, not in the sense of space expanding, but in the sense that the geometry keeps amplifying the importance of tiny differences in how you move. Every possible path forward begins to aim toward the same destination. Different trajectories, different histories, different initial conditions, all converge. This is unlike anything outside a black hole. In normal space, you can move left, move right, turn around, follow any number of future paths. But here, inside the horizon, freedom of direction has collapsed. Inward is no longer one option among many. It is the structure of time itself. You fall not because gravity pulls you, but because space-time leads you there. Just as you cannot stop time from flowing forward, you cannot stop your motion toward the singularity. There is a profound symmetry in this. Outside the black hole, time is the axis that marches forward. Inside, the inward radial direction takes over that role. The singularity becomes your future. Even if you had rockets of unimaginable power, even if you pushed outward with all the energy in the universe, you could not slow the fall. The geometry itself has bent too sharply. Outward thrust would simply become another component of your inevitable trajectory inward. This does not feel frightening from the inside. It simply is. A quiet, inevitable flow carrying you like a leaf in a river of space-time. As the singularity nears, the meaning of space and time begins to dissolve. Distances lose their familiar character. An interval that once had measurable length shrinks towards zero. The separation between events narrows until there is no space left to move through, but your experience of time still feels smooth. Seconds pass as seconds always have. The internal clock of your fall, the proper time, continues its steady rhythm. It is the external description that breaks down, not your awareness. Tidal forces, which were already reshaping the structure of matter, grow without bound. The gradient of gravitational influence becomes so extreme that no physical system can resist it. This is where general relativity stops providing meaningful answers. The theory predicts infinite curvature, infinite density, infinite tidal force. These infinities are not physical quantities. They are the mathematical sign that the theory cannot proceed further without new principles. Some researchers suspect that quantum mechanics may soften this divergence. That at extremely small scales, geometry may not be continuous. Perhaps space is quantized into tiny units, in which curvature cannot exceed a certain maximum. If so, the singularity might be replaced by a region of enormous but finite compression. Others imagine that black holes lead to new universes, baby universes branching off from collapsing matter. In these models, the singularity is not an end, but a beginning, the seed of another cosmos where the internal time continues its flow. There are proposals in which information is stored on the horizon and never truly reaches a destructive end. Ideas in which space-time tunnels into a new region with different geometry. Ideas in which quantum gravity smooths the collapse into a core of exotic structure, a gravitational vacuum condensate, a loop quantum bounce, a fuzzball configuration. Each is an attempt to replace the classical singularity with something more consistent with the rest of physics. But inside this fall, none of these possibilities can be distinguished. They all lie beyond the predictive power of our current theories. What remains certain is that your world line has a finite length. This is the most unambiguous prediction of general relativity. The fall ends in finite proper time. Your personal clock runs out not because of biology, but but because space-time itself has no further extension for you to move into. This is not an explosion, not a sudden burst of energy, not a transition you can feel. It is simply the last moment your timeline contains. It is an ending of geometry. In the final instance, all directions except inward lose their meaning. Space collapses into a one-dimensional funnel. Even concepts like left and right no longer apply. Every point surrounding you is swept along the same trajectory toward the same end. And then, in one final infinitesimal slice of proper time, the curvature grows beyond any finite value. Space-time folds too sharply to support extension. Your path cannot be continued. Nothing about this is violent from your own perspective. There is no sensation of hitting anything, no flash of light, no sound. It is more like reaching the last page of a book and finding that no further pages exist. The story ends because there is no more story. Your entire journey, from the gentle drift outside the horizon to the calm fall inside, has led naturally to this final moment. A moment dictated not by forces but by space-time's deepest structure. The singularity is the boundary where our understanding stops. It is the edge of classical physics, the horizon beyond which new laws may emerge, new ideas may reshape the picture. Yet none of them can change the fact that for any traveler, the fall ends here. Human intuition reaches its limit in this place. Our mathematics reaches its limit. Our theories reach their limit. What remains is quiet acceptance that this boundary is part of the universe's design, a region where reality folds into something we cannot yet describe. And soon, this exploration will ease into its epilogue, not with fear, but with a gentle step back into the wider cosmos, to reflect on the journey, the structure of space-time, and the quiet beauty of a universe that remains far safer and more stable than the inner workings of a black hole might suggest. The fall has ended, and now the perspective will gently widen, drifting outward, toward the calmness of the epilogue waiting just ahead. The journey has carried us into a place few minds ever try to imagine, a descent through curved space-time, a drift across horizons, a quiet meeting with the limits of physics. Now, as we rise back out into the broader universe, there is a stillness that follows the exploration, a sense of the cosmos stretching wide and calm beyond the strange interior of a black hole. For all their mystery, for all their extremity, black holes are quiet citizens of the universe. They do not roam, they do not hunt, they simply sit in deep gravitational wells, curving space-time with perfect mathematical elegance, tugging gently on stars that wander too close, and shaping the slow architecture of galaxies. From the outside, they have no intent, no violence, no desire. They are simply a solution to Einstein's equations, a geometric response to mass compressed into a tiny region, and yet they evoke some of the deepest wonder in all of physics. Thinking about one is like standing at the edge of understanding, looking into a region where everything we know works perfectly up to a point, and then falls silent. In that silence, there is a special beauty, a reminder that the universe still holds secrets beyond our reach, and that the process of discovering them is part of what makes science so endlessly rich. As you drift now, imagine yourself far away from any black hole. Picture the Milky Way spread silently across the sky, a soft band of starlight, billions of suns lying so far apart that collisions are rare even across cosmic time. The nearest known black hole is unimaginably distant, trillions of kilometers beyond anything that could affect you. Even the supermassive one at the center of our galaxy is over 25,000 light-years away, so far that its pull is smaller than the gravity of a grain of sand held in your hand. The deep interior of a black hole is a place we understand only in theory, but the safety of our world is not theoretical at all. It is real. It is stable. It has persisted for billions of years. There is comfort in that, a sense of cosmic steadiness, a reassurance that the extremes of physics do not intrude into daily life, that even the most dramatic objects in the universe exist peacefully in their distant corners of space-time. As you breathe slowly now, imagine floating far above Earth, somewhere in the quiet dark between the planets. The sun glows softly, a sphere of gentle light, and every planet orbits with perfect regularity, unbothered by the exotic geometry we explored earlier. Space, despite its scale, can feel peaceful, not empty, but calm, as though every star is a tiny lantern burning steadily in an eternal night. And somewhere in that cosmic ocean, black holes rest, silent, still, like deep wells in spacetime, shaping orbits, guiding matter, never breaking the harmony of the universe around them. What we explored tonight was not danger, but understanding, not fear, but curiosity, a gentle walk through the edges of known physics. You traced the curvature of spacetime, felt the slow descent toward a horizon, understood the quiet inevitability of falling inside, and reached the boundary where our theories stop speaking. Now, as the mind settles, you can let the complexity fade, as though the equations and the geometry are dissolving into soft starlight. Picture the universe as a wide, tranquil sea, rippling gently with gravitational waves, glowing with ancient photons that left their galaxies millions of years ago, drifting across intergalactic emptiness. In this vastness, black holes are small details, subtle shapes, mathematical shadows that deepen the cosmic tapestry without disturbing its calm. And so, in returning from that interior, you are returning not from a place of chaos, but from a place where nature writes its most precise and elegant geometry. Let your thoughts float outward now, passing beyond the singularity, beyond the horizon, beyond the curvature, back into the smooth terrain of ordinary spacetime. Imagine yourself moving upward, as if rising slowly on a column of light, emerging into a universe that feels familiar again, open, soft, predictable. You are surrounded by the gentle hum of cosmic background radiation, the faint whisper left over from the early universe, a soft glow filling all of space, steady and unchanging, a universal lullaby. Stars spin quietly in the darkness, nebulae drift in slow, painterly arcs, galaxies rotate with a grace that takes hundreds of millions of years to reveal itself. Nothing is rushed out here. Nothing is hurried. The universe moves on a timeline so vast that every second feels like a deep breath. And in that breath, there is peace. As your mind relaxes, you can let go of the intense gravity, the sharp curvature, the inward flow of spacetime. Those ideas can fade like echoes into the distance, leaving only the understanding that you explored something remarkable and returned safely to the gentle calm of the cosmos outside. What remains is a sense of wonder, a reminder that every question we ask about the universe is an invitation to experience beauty, even if the answers lead us to the edges of understanding. And there is comfort in those edges. They are not walls, but horizons, marking the boundary between what we know and what we have yet to explore. As you drift now through this last stretch, let your thoughts widen, like galaxies unfolding, like clusters spreading across the cosmic web, like the slow, gliding motion of stars orbiting their galactic centers. You are part of this universe, made of the same atoms that once glowed in ancient stars, shaped by the same physics that governs black holes, carried along by the same spacetime that curves around every mass. There is a quiet unity in that, a sense that everything from the smallest particle to the largest galaxy cluster participates in the same cosmic dance. And tonight, your journey through the depths of curved spacetime is just one more thread in that vast tapestry. Let the final thoughts settle gently. The universe is stable and wide and deeply peaceful. Black holes are distant, quiet, harmless from afar, simply part of the cosmic architecture. You are safe, small in scale, yet monumental in significance, a conscious mind reflecting on the nature of reality itself. And now, as everything softens, you can let your awareness drift like stardust, settle like cosmic dust on a silent nebula, rest in the gentle darkness between the stars. The journey ends here, but the curiosity it sparked continues, quietly, softly, like light traveling through space long after its source has faded. Rest now, in the calm, in the quiet, in the endless beauty of the cosmos surrounding you.